Okay, so last class we did 4.1, right? And I asked you to do some odd problems, 23 through something. So I planned on asking questions. Do you have any questions? And I realized my homework solution videos, I did all the problems. Y'all know what I'm talking about? Have y'all been using those videos? Yes, for helping you with the homework? Everyone know what I'm talking about? Yes, okay. So were there any questions over those? Yes?
I mean, I just have a question on like how to simplify something because it jump from like one step to another step. And
Okay.
I got the first step.
Which one was it?
It was 43. So
Yeah.
there was like it was like root 4 minus t squared over root 4 minus t squared, and then you change that into 4 minus t squared minus t squared over.
I'm just going to start it. I'm just going to do it because it'll be hard for me to figure out where you are in that. So, and it'll probably benefit the whole class. All right, that is the problem, right? Okay, so the instructions here are to find the absolute maximum and minimum values of this function on this closed interval. So remember last class we talked about we're going to have two methods, right, for finding, well, there's two paths that we're going to be looking at in this chapter. Closed interval method, open interval method. We're looking at the closed interval method right now. We're trying to figure out if you graph this function on this interval, what's the highest point, what's the lowest point, right? So what we need are the critical numbers, so we need to take the derivative. So let's do the derivative. And for this, we have a product right here. And so I'm going to do derivative of this times this, plus derivative of this times this, right? So what's derivative of t? T is like x, right, in the problem? So derivative of t would be 1 times the square root of 4 minus t squared. And then product rule, so plus, now the derivative of the square root part, which is going to be chain rule. Okay, so we could do 1 over 2 roots of 4 minus t squared. And we have chain rule here, right? That's a derivative of the square root of something is 1 over 2 square roots of that something. But then we have to take derivative of what's in here, right? So negative 2t in here. And then you have to finish off the product rule, so multiply by the first function. So that's your derivative. And that, up to this point in this class, that was our raw derivative. We never had to do anything with it, right? Now we actually have to take this, figure out where it's 0, figure out where it doesn't exist. So cleaning up first, I don't need the 1, so I can just write this. Minus t squared. And then here, I'm going to take this. 2 and 2 cancel. I still have a negative, and then t times t is t squared. So I'm going to put on top of t squared, and I'm going to turn this to a minus. So minus t squared over square root of 4 minus t squared. Questions there? That's just pretty straightforward algebra there. Yeah? Okay, now I'm going to eventually have to set this equal to 0, right? So to set this equal to 0, I should probably turn it into a single fraction. That way I can use that idea that a fraction can only be 0 if the top is 0, right? So to get this into a single fraction, that means that I need a common denominator between these two so I can put them together. Yes?
For the equation, the line at the above that one, why is it multiplied by t at the very end?
Product rule. Remember, at the end of the day, we're doing a product rule, right? Derivative of this times this plus derivative of that, which was everything up to here, right? Then times the first function. Yeah. Everyone got that? Okay, I'm going to do a common denominator, so I'm going to look at this as being over 1. And then to put these together, I actually have to multiply. Let me move this equal a little bit. To get the same denominator, that means I have to multiply the top and bottom of this fraction by that denominator, 4 minus t squared. Right? Whatever I do to the bottom, I have to do to the top, right? Because that's really like a 1. And now when I multiply these two together, let me know when I get to the point that you have a clue. Is this it right here? Okay.
Yeah.
All right, so do you understand what I'm doing?
Yeah, I just wasn't sure, like, because in my mind it was like multiply by the conjugate, so I was like confused by, like, because I understood that you have to multiply by top and bottom to get the same denominator.
Yeah.
But then I didn't understand how, like, the root 4 minus t squared times the root minus 4t squared, like, how that canceled out.
Okay. Yeah, so when you multiply, since these are identical, right? These are identical and you're multiplying. You could look at that as being, I'll just do it right here. That's the same as saying square root of 4 minus t squared times itself, right? So squared. And then the square root and the square kill each other off, and you get the 4 minus t squared. Now that just happens to work out nicely there. That just happens to work out real nice up here. We needed this. We didn't do this because we wanted that to happen. We did this because of this, right? We put it here, top and bottom, so that we could put these together into one fraction. So this top right here is going to turn into 4 minus t squared. So this equals, I have 4 minus t squared. That's this numerator, minus this numerator, all over the common denominator, right there. And those t squareds don't cancel, right? They're both negative, so this is going to become 4 minus 2 of the t squareds over the square root of 4 minus t squared. That is a pretty good looking derivative right there. It's pretty clean. There's not much more we can do to it. By the way, this right here would not be okay, right? When you take the square root of 4 minus t squared, this is not equal to 2 minus t, right? That's not the way algebra works. When you have a square root and you have subtraction or addition, you cannot do the square root of each one. If it's multiplication, then you can do the square root of each one. But it's addition or subtraction, you can't, right? So that's not true. So we just have to leave it like that. We good? All right, now what we want to know is when is this 0 and when is it undefined, or when does it not exist, right? I want to leave the screen up today. I know that some of you are real far over there, but if y'all want, y'all can move a little further this way if it's too far for you. I don't like the way the videos are coming out. They're blurry, they're real far away, so I'm going to try and like focus myself on this side of the board a little bit more, just so that the video I can zoom in and it'll come out better. Okay, so we want to know when this is 0, so here we go. We're finding the critical numbers. I want to know when is f prime equal to 0, right? And I also want to know when does f prime not exist, or where is it undefined? You can say it either way, I don't care. Undefined or not exist. So I'm going to take a look at that derivative. And first, to figure out where it's 0, all I have to do, since it's a fraction, a single fraction, is just look at where the top is 0. Right? We talked about that last class. So this reduces to saying when does 4 minus 2t squared equal 0? And that's just a little quadratic equation. You can solve this various ways. If it were me, I don't know, I'd do a lot of things. I maybe take the 2t squared off to the right side, add it to both sides, divide by 2. T squared has to be 2, and then take the square root on both sides. And if I take the square root on both sides, I'm going to have plus or minus square root of 2 equals t. And I have to remember, what was the interval? What was my interval? Negative 1 to 2. And so only one of these lives in that interval, the positive square root of 2. The negative square root of 2 is too far to the left. So my only answer for a critical number is this, right? And then where is it undefined, or where does it not exist? So this is the tricky one, I think. When you look at this derivative, the only place it would be undefined or not exist is when you would have division by 0 or square root of a negative number, right? Because you have a square root here. So first of all, let's see, what would it take to get 0 down here? What would I have to have for t? 2 or negative 2, right? Well, let's do negative 2. Negative 2 isn't in here, right? So I don't need to consider that. And then positive 2 is in here, right? But it's also an endpoint. Remember, in this method, we're going to check the endpoints anyway. But technically, t equals 2 is a critical number, because it is a point that if you plug 2 in here, This is undefined. And 2 is in the original domain of the function, right? The original function was t square root 4 minus t squared. We can plug 2 into this, right? 2 can get plugged in here because you just get 0. But you can't plug 2 into this because you get division by 0. See the difference? Okay, are there any other points that would make this undefined? Or any other values of t that would make this undefined? Yeah, there are numbers that could screw this up, right? If I try and plug 3 in here, you get 3 squared is 9. 4 minus 9 is a negative number. You can't do the square root of negative, right? There's a bunch of points that would mess it up. However, in the original domain, if you plug in numbers between -1 and 2, that's defined, right? So this should be our only point. Or we have 2 critical numbers, right? So now what we do is we're going to take the original function, we're going to plug in the critical numbers, root 2, and then we're going to plug in, I could plug in 2, but I'm going to do it anyway because I have to do endpoints, right? So there are 3 values that I'm going to plug into this function, those 3. And then I plug them in, and I see, once I plug them in, what's the biggest number I get, what's the smallest number I get. So let's try this. If we plug in root 2 into this, right, into that, we get root 2, and then we get square root of 4 minus root 2 squared. So this is root 2 square root of, root 2 squared is just 2, right? Root 2 squared is 2. 4 minus 2 is 2, so we have root 2 times root 2. That's just 2, right? Because that's the square root of 4. And then -1 in here, we get -1 square root of 4 minus -1 squared. This is equal to -1 square root of 4 minus, when you square -1, you get 1, so 4 minus 1. And this is -1 square root of 3, or negative root 3. And then when I plug in 2, we just talked about this a second ago. If we plug in 2, we get 0, right? Because this will be 2 times the square root of 0, which is 0. So the absolute maximum is this number right here. That's the absolute maximum. Because that's the biggest number, right, that comes out, 2. And then the absolute minimum would be this number because it's a negative number, right? This is 0, negative number is smaller, so this is our absolute minimum. Questions? Sure? Okay, just fair warning. I'm expecting that everyone in this class has done the 4.1 homework. If you haven't yet, you will have that done. Because for those of you who did it, there's a lot of algebra in there, right? There's a lot of algebra in there that we haven't talked about. And so I don't want to go and do those problems because I did them all on video already. So I guess my warning is, don't just sit here and say, yeah, I get this, without having tried this homework. You need to have done this homework or else you're going to suffer when it comes to the test. All right? So are there any other questions? Right, this question was about algebra, right? So good. I mean, that's what I want to clear up. I've erased it. But any other questions on homework problems that you need me to clarify any of the algebra? There were problems where you had to solve trig equations, right? Did you have any questions about that?
I got a little left on 31.
31?
Yeah.
Okay. Yeah, x to the 4/5, x minus 4 squared. So f of x equals x to the 4/5. And then what was it, x minus 4 squared? Okay. So in this question, it's asking you to find the critical numbers. That's it. It's not asking you to find the absolute max and min. It doesn't give us any endpoints. It just wants you to find critical numbers. So take the derivative, figure out where it's 0, figure out where it's undefined or where it doesn't exist. So we need the derivative first, and that's going to be where things get weird, right? So we take our derivative, and if I were doing this, I would see product rule again, right? Right here. So I would do derivative of this, and I'm going to have to use power rule for that, right? So I bring the 4/5 out front, x, and then I subtract 1 from that. 4/5 minus 1 is the same as 4/5 minus 5/5, negative 1/5, right? Negative 1/5. That's the derivative of the first one, times the second one, plus, now the derivative of the second one, I mean the derivative of this, right, would be chain rule, right? Because you've got that thing squared. So you've got to bring the 2 down in front of x minus 4. And then that's to the first power now, right? Then times the derivative of what's inside, which is just 1, so I don't really need it. And then I have to finish off the product rule, so x to the 4/5. Any questions about that derivative, about that raw derivative? No? You have a look like, you have a question or no? No? Okay. All right, so now I have to figure out where this is 0, right? And that looks terrible. I'm going to have the same sort of goal. I'm going to see maybe this is a fraction I can put together. The reason I'm thinking fraction right now is because this is to the negative 1/5. And that means it really lives on the bottom, doesn't it? So I'm going to rewrite this. See if you can follow me here. The 4 and this piece right here are both in the numerator. So I've got 4, I've got x minus 4, that's squared. And then what's in the denominator is the 5, right? And this is going to drop down with it. So I'm going to have 5x to the 1/5. Plus over here, really I can't do anything with this. I'm going to put it in a different order though. This is just my preference. I want to put this next to the 2 instead of having it off on the back side. Okay? If I'm going to put these together at this point, I'm going to look at this as being a fraction over 1, and then I have to multiply the top and bottom here by whatever would get me a common denominator. So I need to multiply by this, right? This needs to multiply on top and bottom there. So we're going to go here, 5x to the 1/5. And I should state that this is not the only way you can do this. Like there's other algebra that you could do that you could get to the same result. Some people, they would factor, that's fine, whatever. I'm just doing it the way I do it, all right? So there we would have the same denominators now, right? When we put these two fractions together. Okay, so where are we at? Let's see here. We've got equals. All right, I'm going to have, let me go ahead and just multiply. Let's talk about what we get here. The 5 and the 2 would give me a 10, right? Let me leave the first one alone. I'm not going to put them together yet. 5x to the 1/5. And then I have plus, okay, when I do 5 and 2 together, I get 10. And then, yeah, this is the big one right here. This is the one that's really helpful. This times that. You add the exponents, and 4/5 plus 1/5 is 5/5, and 5 over 5 is 1. So that's really just x, right? So 10x, and then we just have the other factor there, x minus 4. So that's what that numerator becomes, right, when you multiply that together. It looks a lot worse than it turns out being, right? And then the bottom is, of course, the common denominator. And then here, now we can put them together, right? So we have 4x minus 4 squared plus 10x, x minus 4, and then all of that over 5x to the 1/5. Now it's not pretty, but that is the derivative, right? And I've got it turned into a single fraction at this point. With me?
Pull out the x minus 4.
Yeah, so the question is, I'm going to have to set this equal to 0, right? I'm going to have to set this equal to 0, and there's a lot of ways to do that. You could FOIL this out, expand this, and then multiply 4 through. You could do that and distribute a 10x through. You can do all that. Or you can see there's something else you can do which is a little cleaner and faster. So let me get to what we're doing right now. We're gonna figure out when this derivative is 0 and when it doesn't exist. So when is derivative 0? where does the derivative not exist? All right, so when is it 0? I'm going to set the top to 0, right? So 4x minus 4, that squared, plus 10x, and then x minus 4. Hey, what's going on over there? Why did it time out? Oh, because I'm not plugged in. Let's see what happens. Does it come back? There we go. All right, so like I said, you could expand all that out, like multiply that out, distribute forward, distribute, but it's cleaner if you realize that these both have one factor of x minus 4 in them, right? They both have an x minus 4. So we could pull an x minus 4 out of both terms. Also, you could pull a number out, right? There's a 4 here and a 10 here, so you could pull a 2 out. So from this expression, I'm going to pull a 2 and an x minus 4 out front. Now I'm going to put a bracket, even though I could use a parenthesis. I'm going to use a bracket just so hopefully everyone sees this. When I pull 2 from here, I'm left with 2. And when I pull one of the x minus 4 factors out, I'm left with one of them still, right? So I still have an x minus 4 there. Plus, now I pulled a 2 from this, right? So I have a 5. I did not pull the x out, so the x is still there. And I pulled that factor out, didn't I? So that it's not there anymore. So that's all I have. That equals 0. Now this is a nice little linear expression. Just distribute through here. You get 2x minus 8 and then plus 5x, right? That's what you would have there. So we get 2x, 2 times x minus 4. And then this right here, I'm not going to use a bracket anymore. I'm just going to use parentheses. Would be, what? 7x minus 8. All of that has to equal 0, right? So now that you have it completely factored, you can set each factor equal to 0. Now we can ignore the 2, because if you just divide both sides by 2, it's gone. So I really need to set this equal to 0, and then I need to set this equal to 0. And so here I get x is 4, and then here I get x is, you move the 8 over, divide by 7, you get 8 over 7. Way earlier, yeah. It will work, but you just have to be careful. Was there another question, Josh? Okay. All right, so we've got 2 critical numbers, right? And remember, this problem, they don't give you an interval. So we're just finding critical numbers, there they are, all right? And now we have to figure out where it doesn't exist. So look at this derivative, right? The only issue I would have here is if the denominator was ever 0. Right, because that's really, what does 1/5 power mean? Do you all know what that means? 1/5 power really means the 5th root of x. Are we all comfortable with the idea that when you have a square root, you can't have a negative here? But if you have a cube root, you can, right? You can put you can't put a negative here, but you can put a negative here, right? For example, negative 8. Square root of negative 8, or sorry, cube root of negative 8 is negative 2. Because if you cube that number, you get negative 8. So you can have negatives under cube roots, you can't have negatives under square roots. If you have a 4th root of a negative number, let me put negatives under these. Square root of negative 8, can't do. Cube root of negative 8, can do. 4th root of negative 8, can't do. 5th root of negative 8, can. If it's odd, you can have a negative under the root. If it's even, you can't. All right, so here, it's okay to plug a negative in, but you can't plug 0 in. Because if you plug in 0, you get 0, right? And division by 0 is undefined. So the only critical number we would have here is if x is 0. So we have a total of 3 critical numbers. All right, good. Questions? Comments? Complaints? No? Please do the homework, okay? Make sure your algebra, the algebra that happens in the homework makes sense to you. We'll get more practice with it in 4.3, but you know, we just don't have time to just go through all the algebra that comes to play now. All right, we're going to move on. 4.2. So let me tell you, last class I said there's two methods we're focusing on this chapter, right? Closed interval method, open interval method, right? We pretty much have the closed interval method done, all right? It's done. We are going to do open interval method, but first we're going to just exit the highway for a second and we're going to go eat lunch, okay? We're going to have this little side thing, okay? It's not tied to the closed interval or open interval. I don't personally like where it is in the chapter. I wish they just pushed it to the end, but I'm going to follow the sequence in the book. So this is just a little timeout detour, okay? We're going to talk about this thing called the mean value theorem. Then we'll get back on the road, okay? So this is actually something that you can think of, and I think you can rationalize this pretty easily in your mind. Let's say that you take a trip to Austin, okay? Let's say that you drive north Austin. Let's say it's an 80-mile trip, and it takes you 2 hours, all right? I'm going to draw a picture. By the way, this is tied into something that we've talked about already. So time, let's say in hours, we have this trip. This is our distance, and let's say this is in miles. So you start your trip, right? You're sitting in your driveway or whatever, getting ready to leave. At time is 0, you've gone 0 miles, right? And then, I'm going to say 1 hour. 2 hours later, here's what I tell you. You've gone 80 miles and you've arrived at your destination, all right? Can you tell me my average speed, or your average speed? What's your average speed? 40 miles per hour. So how are you getting that? Your average speed would be equal to your total distance, right, that you traveled, over the total time. And the total distance you traveled was 80 miles, and you did it in 2 hours. And so that would be 80 divided by 2 is 40 miles per hour, right? So I'm just going to put MPH. You travel 40 miles per hour on average, right? So your trip, the actual trip, you know, you leave, you speed up, slow down, right? So your trip is going to look whatever it looks like, right? The average speed, geometrically, can someone tell me what the average speed is geometrically on that picture? The average speed. What is it?
Wouldn't it be y equals x?
Well, that's assuming it's diagonal. The way I drew this, it looks diagonal. You're on the right track. It's not necessarily y equals x, though. Just geometrically. Draw this straight line connecting from here to here, right? Whatever the slope of that line is your average speed. Why? What's the slope of this red line? Rise over run? What's rise? 80. What's run? 2. 80 divided by 2, right? So the slope of this line, the red line, is equivalent to your average speed. But that's not your speed at every point on the trip, right? Throughout your trip, you're going different speeds. So in calculus, what we've been doing is we say, okay, at certain points in the trip, we have certain speeds, and that's equivalent to the slope of the tangent line, right? At that point, that would be your speed at that instant in time. So what the mean value theorem is talking about is this. If my average speed, all right, imagine this trip to Austin. If your average speed was 40 miles per hour, does that mean that you had to have gone 40 miles per hour at some point in your trip? Looking at your speedometer, right? You go to Austin, you get there, you say, hey, 40 miles per hour was my average speed. Do you think we can then guarantee that at some point in your trip, I don't know which point exactly, but guaranteed at some point you had to have been going 40 miles an hour?
Yes.
You all agree with that? That seem reasonable? It would be impossible to average 40 miles an hour without actually ever going 40 miles an hour, right? That's what the mean value theorem is saying, is that if you have a continuous function, right, on a closed interval, that at some point in the trip, I must have gone my average speed, which geometrically means this. At some point in my trip, somewhere. I think it looks like about right here. Do you agree that the slope of the tangent line, right? The slope of that tangent line is parallel to the slope of the red one, right? This is my average speed. That's my instantaneous speed, right? Do y'all see? At some point in my trip, I don't know, whatever this is, I'm going to call it C. At some point in my trip at C, my instantaneous rate of change was equal to my average rate of change. Is that the only place it looks like it happens? It looks like it happens at a few other places, right? It happens, just the way I drew the picture. It looks like it happens here and maybe somewhere around here. So it looks like maybe the way I drew it, that there were 3 different places in my trip that I was going exactly 40 miles an hour. Does that make sense logically to you? No questions? Okay, so that's the main idea. Let me start it from the beginning and let's get us there. And then I have, you know what? I'm wondering, we have like a really interesting question. Let me show you the interesting question first before we do any theory here. I threw this together real quick before class, so I don't know how this is going to go. All right. So what I have here for you to ponder is I have 2 cars, okay? I have a red car and a blue car, right? And they are at the starting line of a race. They're going to start here, and this is the finish line. They're going to race to the end, right? Ready, set, go. Okay, they go. Right, blue one's winning. Here comes the red one. And they tie, okay, at the end. All right? What's that? Yeah, so I want you to consider a race between 2 cars where they start together, right? They start at the same time, and they race. Now, it doesn't have to look exactly like this. Just imagine 2 cars racing. One could pass the other, you know. But at the end of the race, they're tied. So they start tied, they end tied. Okay? Imagine that hypothetical situation. Do you think that there is a point in time, somewhere in the race, where both cars have to be traveling the same speed? I want you to think about it. Absorb that question for a minute. Is there some point in time in the race where when both drivers look down at their speedometers, they see the same number? Yes? Y'all think so? It's the same point in time for both cars?
Yes.
That's the big part we have to agree upon. I do agree.
Yes.
So let me back up. They both start at the same place, right? And they both end at the same place, and they do it in the same amount of time. Because they tied, right? That means they both have the same average speed, don't they?